Hey there, CS210 students. Let's talk about Chapter 4. And in Chapter 4, we're going to be talking about functions that we write in C++. So again, you've all had a Java or a Python class where you would have written some functions in that class. So keep in mind that the idea of a function is creating groups of predefined statements for repeated use. So anytime you take some code, copy and paste it, you should probably write a function. Okay. So any duplicated code, go write a function that handles that work. So the example that we have in our code here is a calculate pizza area function here. Now, my first issue with this function is it should be written with a lowercase first letter. I think the zyBooks assignments, you have to capitalize the letters, but any code that's going to be submitted to me in a Visual Studio project should be written with a lowercase letter. So we use capital letters to represent the name of a class, not for a function. But this calculate pizza area, what it does is it calculates the area of a pizza. And so we have a diameter of a pizza, we can calculate its radius. Eventually we're going to calculate the area, that's the value that we want out of this. And then remember, pizzas are circular, so they've got a value for pi out to, 7 or 8 digits here. And then this is an example where the pizza diameter is set to 12. It doesn't specify what the units are here, right? So I guess we're going to assume that it's 12 inches. So we got a 12-inch diameter pizza. To get the radius, we take that and divide by 2. And then to calculate the area, it is the pi value times the radius squared. And to square the radius, they've just multiplied it twice. And at the end, they're returning the value of pizza area. So when you create a function, you have to have the data type that it's going to return, the name, and then in this case, this does not take any parameters. We'll see here in a few sections or in a few minutes here that we can pass values to it. And then this does all of the work. And in this case, this returns the value of pizza area. If we had a function or a method that just simply does work, you'll be printing menus in our class. So you'll have a method called print menu. So the syntax of it might look something like this. So we'll have a void method. So void print menu, print the menu choices, and then we end the block. This would not have a return statement. So if it's a void method, that just simply means it does work, but it doesn't return anything. And again, this would be a print menu choice type of deal or print output. That's what this void method is going to be used for. Okay, so let's continue down. So we can make our functions a little bit smarter by providing values to it as input. So two terms. First off is parameter. That's the function input specified in the function's definition. So down here, I've got this method called print pizza area, and it is going to take a parameter for the diameter. So this is called a parameter. This is a placeholder. It's a variable that I'm going to have to send a value to when I use this method. And then when I use the method, the value that's actually provided to the method in my code is called an argument. So this method print pizza area, I could give it 12, so I'm going to give it 12 inches as a parameter, or I might give it 16 inches as the parameter here. So this method has now been updated, been changed, where we don't have a constant value that was assigned for the pizza diameter. We can pass it in. We'll still calculate the radius, that's the diameter divided by 2. We still calculate the area. And then this method prints out what the diameter passed in was, and then prints out the area. If we didn't want to make this a void method, if we wanted it to be a value returning method, so instead of calling it print pizza area, if we still had that calculate pizza area, all we would do is just simply return pizza area like that. Okay, so, oh, and then I have to say return, this returns a double value. So the compiler will yell at you if you say that this is a void, but try to return, excuse me, return a value, then the compiler is going to give you a syntax error, and then vice versa. If this is not returning a value and this says void, or let me back up. If this says void, you try to return it, syntax error. If this says double and you don't return a value, you're going to have a syntax error. Let's see here. You can pass in multiple parameters. So they've changed the pizza calculator to be pizza volume. So it's not just area, but volume. So we're going to have a nice Chicago style deep dish pizza here. So they're going to have the diameter passed in as well as the height of the pizza. They'll still calculate the radius. They're going to calculate the area. And then we're going to have a volume value that gets calculated. Still have pi. And then they're going to calculate the radius, and they're going to calculate the area right here. Wait, hold on. This is duplicated code, correct? Shouldn't they have done something like this? So instead of this code right here, couldn't they have said pizza area equals calculate pizza area, and then pass in the diameter? Right? Isn't that what this thing takes? It takes a diameter, and we've got the diameter. It's been passed in. And so we got the pizza area right here. So don't duplicate code. If you have code that already does something for you, reuse it. Okay, so you get the idea of that one. And okay, so let's move on to the next section. So here again, I've already kind of hit on it multiple times. So a function may only return one value using a return statement. So they're showing here that we have a method that computes a square. So you give it a value and it just multiplies by itself and returns. Great. Otherwise, we might see where we declare a variable, we do some work, they're going to print out an output here. All right, sorry, this is the usage of it. Sorry, let me back up. This is the usage of it. So we call the compute square method and we pass in a value and we get it back here. And then once it's returned back, we can then use it in our code. So this is one thing that new programmers will struggle with. Let me just jump back here. Is you declare the method and then it requires a value to be sent to it, and then new programmers often struggle with, all right, so how do I use this thing? So keep in mind you use it by reusing the name, and then if it requires a value, you have to give it. And in Visual Studio, if you don't provide a value, it's going to yell at you. You'll have a syntax error, and then you can come back here and look at what the definition of compute square is. Another issue that new programmers struggle with is if a method returns a value, so we've got an int return type here, and it returns a value, then that return value should always be assigned to a variable. And the variable type that it has, so it's got to be the same data type. So if I'm returning an int, then I need to return it to something that can hold an int. Okay, let's jump to section 5. And one thing that I introduced and provided to you for project 1 is a unit test for the functions that you have in project 1. So the idea of unit testing, which we work with functions, so we want to test the accuracy and the work of a function, is that we can wrap up all the calculations or whatever we need to do in the function, and then we can write a test for it in C++. So in project 1, I provided you a gtest file that you're running in Visual Studio. But they're just simply showing you a way to test it. This would be a very kind of basic way where you had to have copied and pasted. So you copied your code. So you got a function called hours mins to minute. So we're converting hours and minutes. So you can see they've got total minutes. We take the hours times 60, and then we add the original minutes, and we're going to spit back that value. Let's see. So this actually has a bug, doesn't it? So we want to return total minutes here. But what we can do is we can test it by sending it all different types of values and seeing if we get the right responses back. And as we can see here, we expected to get a 60 and a 300 and 150, and so this failed. So this gives us a chance to test it and make sure that it works properly. Um, they introduce here that we have an assert library, so they include that. And so the assert library says, hey, give me what the actual value is on the left and then compare it to the right. And this would spit out a failed for anything that is not true. So this is a nice little kind of a simple way to hook up a unit test. Again, what you have to do here is copy and paste the code, whereas in the project one, that's the way that I want you to kind of implement unit testing if you're going to do it. I hook up a connection to the method that's being tested, and then we assert it that way. All right, let's jump to section 7. So some common errors. So let's say you're going to create some functions that calculate Celsius to Fahrenheit and Fahrenheit to Celsius. So we've got the Celsius value that we send in. We've got the converted temp that we're going to calculate here. So eventually we're going to return the Fahrenheit value. And to convert from Celsius to Fahrenheit, you take 9/5 times the Celsius value, and then eventually add a 32. And then that is Celsius to Fahrenheit. Well, what they did was they copied this code, pasted it, and they said, all right, give me the Fahrenheit value. We're going to convert. We're going to have a Celsius value at the end, and we're going to do the opposite. So we're going to take the value, subtract 32. We're going to do the inverse of this, which is multiply by 5/9. But then look, they return Fahrenheit value right here. They didn't change this code right here. So again, a common error. Anytime you copy and paste code, you have to be very careful. Make sure that you're changing all of the values that you copied and pasted. Okay, next thing is we can write functions that pass a variable by reference. So the first examples that we saw, if we had parameters, we were passing them by value, which just simply meant we were getting a copy of what the argument's value was. So here we have time val, hour val, min val. So these are being passed by value. And so the usage is right here. So same function, convert hours to min. We get in the variable values, we send them, and then look, they're going to say HR val equals something. They're going to try to override our value. And same thing with min val. They're going to try to override that value. Well, when you pass things by value here, this has nothing to do with the value afterwards. So whatever we sent to this method, whatever was typed in, so in this case it was 0 and 0 here, we would get 0 and 0 back. Nothing would have changed with these two variables because they're passed by value. So if you wanted to change the actual value of this variable that was sent in here, then you have to do a pass by reference. And so C++ lets you pass by reference where you have to give it the variable's memory location. And to do that, the syntax is to declare the parameter as a reference variable. So the ampersand is provided here. So int ampersand says, all right, you give me the address of our val, and inside here, when I do the exact same work, I am now changing the variable value. I have access to the variable value, the memory location. So after this code executes, so originally we sent in zeros. So 0 got sent in. When we divide by 60, that would still be 0. What do we send in for min val? Oh, this isn't, we're not changing anything here. Do they have an example? They don't. So let's say that these were 120, or sorry, this is what, 2 hours? Oh, wait, this is time val. Hold on. So if they send in numbers that would actually be changed, then these variable values are going to get updated down here. Now, my take on pass by reference is this. While you can do it, I typically try to avoid it in production code. I really don't want my methods probably changing the values of variables. In section chapter 3, we talked about variable scope. So let's talk about variable scope again in terms of functions. So we learned that scope is the block of code that something's declared in, and it's restricted to that. So if I have a function here, again, it's a block of code because it's delineated by an open and closing curly bracket. So this variable cmval right here, it's declared in here, and it's returned at the end. But if I try to access cmval afterwards, so if I had any code that tried to use cmval, I'm going to get a syntax error. So it is local to this function. It's just a helper variable. It's what we are going to return at the end. So a consequence of this, so any variable is declared outside of a function, we call it a global variable. So local variables are declared inside a set of curly brackets, but a global variable is declared outside of those curlies. The thing about a global variable is anybody can access it. So you have to be very careful with global variables. If you're expecting a value and it gets updated somewhere else, that's a consequence of it being a global variable. Typically, we try to limit the scope of a variable so that way we don't get updates to something that shouldn't be updated. Next thing, so not only do you have variable scope, but you kind of have also a function scope. And so if we're writing code in our main method, so here's a sample file and here's the main method here, anything that main wants to use has to be declared and defined above it. So that would be great. So we got this true current dollars method. So if this method, all of its details were pasted up here, then we could reference and use it down here. However, C++ is not like Java. If I don't have it fully declared, then we have to provide a prototype declaration for it. So what this means is there's going to be a function called toCurrentDollars. It's going to have a parameter for past dollar, past year, current year. So it's a double, an int, and an int. In fact, you don't even have to put in variables here. I could just say double, int. I provide the data types that it will have. Then the main method will say, okay, you've got toCurrentDolls. Great. All right. So I know that it's going to be declared somewhere. It has to be. If it doesn't get declared, it won't compile. But I'll know about it. So, yep, I'm good. And then you define it down here. So this is the function prototype or declaration, and then this is the actual implementation of it. Later on, we'll see when we have separate files created that we can define the functions in one and then implement them in a separate one, which will kind of lead to our class functions when we get to that in a later chapter. Some versions of C++ let you have what are called default parameter values. I've gotten used to this using some Python over the last couple months. So a default parameter value is great for providing a default value. So we've got current day, current month, current year. We're going to print some date. And then we have a print style, and they're saying that 0 is American, that's the default, 1 is European. And we could have a list of, different types of date styles potentially. But what this does is we can just use this method and say current day, current month, current year, and I don't have to provide this value. So that's what they're doing right here. So they're saying 30 is the current day, 7 is the current month, 2012 is the current year, and that they didn't provide a value for print style, so it would be using the default of 0, which is the American style. These two examples provide a value for it. This one does not. Now, keep in mind, most programming languages, C++ included, if you start providing a default parameter value, anything after it, any parameter after it is also going to have to provide a default parameter value. They're not smart enough to figure out what is missing. C++ provides what's called function name overloading, just like Java. Python does not have this. And the idea here is I can create two methods. So here's date print, here's a different date print. And what has to happen with them, they can be the same name, but their signature, their parameter list has to be different. So you can see they both take an integer for current day. This one takes an integer for the current month. This one takes a string. So this is the part that's different. So I can call this method 30 with 7 in 2012. That's going to call this one right here. The one that has the string, that's where this is going to be called. So when I call this one, I will be using this method and not the integer one. So in C++, if you try to declare two methods that were called date print, and you went int, 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 and then this is also 3 ints, you're going to get a compiler error because you cannot have a duplicated method with the same signature. However, if something in the signature is different, like this case right here, then this is perfectly acceptable. One thing that you might want to do in your functions is check if a parameter is valid. And what they're going to do in this here is they're going to check current day. So they're going to check if it's less than 1. So you can't have a negative value or a 0 for a current day and a date. So if that's the case, or if it's greater than 31, then they're going to print out an error message. And then you can see they set current day to 1. So they're going to default it to 1. And they're even spitting that out to the user. Hey, that's invalid that you gave me. I'm going to use a 1. Same thing with the current month. They validate it. And if it's not valid, then they're going to use a 1 right there. So kind of a nice little check here. If something's not valid, they're going to use a default value. You'll see in chapter 5 where we could potentially handle this case with an exception and then not do anything based on invalid input. Okay, in 4-15, let's say that we want to put some methods in a separate file. One thing that we will do is we'll create our file, but to use it in something else, we have to have an include statement. So two different formats of it. There's #include, just the file name, or in angled brackets. So the difference between using the quotations and the angled brackets is this. If it's something that you've created, so you'll see in our class eventually we'll be creating classes. If you create it, it's going to be wrapped in double quotes, and you're going to say the file name .h, reference the header file. If it's something that's coming from a library, it's going to be in angled brackets, and it's just going to be the library name. And you've done this already where we've had #include string, #include IO stream, or did I say stream? #include string, and then #include IO stream. So if it's a library, it's an angled bracket. If it's something you create, it's going to be in double quotes. And so what we can do to make things a little bit more testable, we talked about unit tests earlier, is we could create a file. So we have a file here that's going to deal with 3 integers. We might calculate their sum, we might calculate their average. And in C++, to hook something up as a module or as a class, it takes 2 parts. It takes a C++ file and a header file. The header file just simply says there is going to be something declared that will implement this signature. So 3int sum with 3 integer parameters. And again, in the declaration, I don't need to specify a parameter name. In fact, I could just say int, int, int. And then in the C++ file, this is where I'm going to actually implement the method. Here's the 3int average declaration. Here is its implementation. And then the C++ file is going to have a pound include the header name. So they don't have that in here, but this would also be inside here at the very top. So then I can come over here, and if I want to use these methods, I'm going to include the header for it, because this is a declaration that says, hey, there's going to be a 3int sum. Compiler, eventually you'll figure out where it is, and then I can utilize those methods. So this would be a great way to declare functions in kind of a helper class, a helper module, and then we could write test code, we could write unit tests to make sure that these function properly. Last thing, if you scroll down, we can provide header file guards at the top of our .h file. So we say if end def, and then we give it the name here, and then we say pound defined, and then an end if. And so this is a representing the file name here. And the usage of this is this will only pull this header in one time. One thing that C++ makes difficult is compiling the code, and if you try to import this header file multiple places, you may be getting a compiler preprocessor error that could be tricky to track down. So put in a guard so that this is only handled one time. Okay, that's it for chapter 4. I'll talk to you next time.